Hello, this is just a quick tutorial to show you how we can determine what the state of matter is of a substance at different temperatures. So, for example, if you're asked a question, what state of matter would iron be in at 2,200 degrees Celsius? What state of matter would iron be in at 10,000 degrees Celsius? So it's to help you to figure out whether something is a solid, a liquid or a gas, depending on what temperature it is at. So the first thing to make sure that we understand is this idea of melting point and freezing point and the changes of state associated with that. So the melting point is when you have got a solid and you heat it up, you provide a higher temperature and more energy so those particles move around a little bit more, and that solid will melt and it will change state into a liquid. So you're going from a situation where you've got all of the particles touching in a regular arrangement, providing more energy for those particles, the forces of attraction between those particles can be overcome, and you turn that into a liquid where there's no regular arrangement of particles. They're touching but they're able to move over each other. Freezing point is the opposite, and freezing is when you have got a liquid and you cool it into a solid. So we're just going the opposite way around, liquid to solid. Okay, now let's use water as an example. So for water is when it's solid, we call it ice. So we've got solid water, which is ice, and when it melts, that solid water will turn into liquid water. That happens at the melting point of water, and the melting point of water is 0 degrees Celsius. The freezing point, so when liquid water, so we've got normal water at room temperature and we cool it down, it turns into ice. That happens at what you might want to call the freezing point of water, and that also happens at 0 degrees Celsius. That means that melting point and freezing point are exactly the same thing. Now, scientists don't like having two words for the same thing, so even though at 0 degrees water can melt and at 0 degrees water can freeze, because we're scientists and we like simplicity, we're just going to stick with one word and we call it the melting point. It doesn't matter whether you're going from solid to liquid or from liquid to solid, we will call it the melting point, but we know that it's the temperature where something will melt or freeze, and it's the same number. Okay. Equally, boiling point and condensing point, they would be the same as well. So water would boil at 100 degrees and it would condense at 100 degrees, and we just call it boiling point instead of having two words, boiling and condensing. Okay, so as long as we're happy that melting point is one word, but it could mean either melting or freezing because it's the same temperature. If you've got water at exactly 0 degrees, then what you've got is about half of it in liquid form, half of it in solid form, and the liquid is changing into solid and the solid is changing into liquid constantly. That's what happens at exactly 0. Okay, so let's have a look at some examples where we're looking for which state things are in at different temperatures. Okay, so let's start with water because it's one that we know. Let's just put our degree symbols in because I haven't got a degree symbol. There we go, degrees. So question says, what state of matter, so that means solid, liquid or gas, is water at these temperatures, -100, 20 and 200 degrees Celsius. So what we need is some sort of number line that represents temperature, so like a thermometer, and we need to show where the melting point and the boiling point of water might be. So I'm going to use this thermometer just for now. So let's say that this here is 0 degrees Celsius, this is 50 degrees Celsius, this is 100, and this is 150. So we've also got some negative numbers. So on the same scale, this would be -50 because we're going up in 50s. This would be -100. This would be -150 degrees Celsius. Okay, so we've got a number line. And we know the melting point of water is 0 degrees Celsius. And we know that the boiling point of water is 100 degrees Celsius. And what you need to make sure is that these numbers can fit somewhere on this number line or thermometer. So let's put those on there. Let's grab these. Okay, so for water, there's your melting point and there's your boiling point, and I'm going to just draw through there so that we can separate those off. So at these points, this is your boiling point, your melting point. Now we need to add on what state substances are in, above, below, and in the middle. Okay, so here we've got the melting point. If you go colder than the melting point, then colder, you end up with a solid, because you have frozen your substance at the melting point. If you've got a solid and you go past its melting point, you've heated it past its melting point, it will melt into a liquid. And if you've got a liquid and you heat it above its boiling point, it will boil into a gas. Okay, so now all of this section of our number line is a gas, all of this section is a liquid, and all of this section is a solid. Let's go back to the question then. Question says, what state of matter, solid, liquid or gas, at minus 100? So we just need to find that on our number line. So minus 100 is here, and we can see that minus 100 is solid. So ice would be, water would be solid ice at that temperature. Next question says 20 degrees, so we need to find that. 20 degrees would be here somewhere. So let's put it here out the way where we can see it. And you can see 20 degrees is in the liquid section. So at 20 degrees, water would be a liquid. So that's about room temperature-ish. And the final one is at 200 degrees. So 200 degrees doesn't even fit on our number line. It would be way up here somewhere. So let's draw that in. 200 degrees would be somewhere there. And you can see that it's in the gas section. So at 200 degrees, it would be a gas. And that is how you answer that question. You draw a number line. I've used a thermometer. You draw a number line. You mark on the melting point and the boiling point. Section it off. Right where it would be a solid, a liquid and a gas. And then you're all set up to answer your questions. And you just need to look for these temperatures on your number line and find out where they go. And that is how you answer these. Okay, so let's do another example. This time I'm going to draw the number line straight, like you probably would, because you're not going to waste time drawing a thermometer. Okay, so in this one, what state of matter is copper at these temperatures? Now, copper is a different substance to water. It'll have a different boiling point and melting point. So let's write those down first. Copper's melting point is 1085 degrees Celsius. Copper's boiling point is 2562 degrees Celsius. We've got different melting and boiling point to water, as you would expect. So again, we're going to draw a number line. So let's see if we can draw a nice straight number line. There we go. That'll do. And we want to make sure that on our number line we can fit these numbers. Ideally, we'd fit these numbers as well, but they're quite far apart. So I'm going to make sure we can at least fit these numbers on. So we're going below 1,000 and above 2,500 roughly, and we want to make it a nice scale. So we want to go up in a times table, something like that. So let's go from, we'll put 500 degrees Celsius, 1,000, so we're going up in 500s, 1,500, 2,000, 2,500, 3,000. Okay, so there's a number line. Now you can go up in whatever numbers you like, as long as it's a nice regular pattern. That's a good idea, and as long as you can fit these numbers on. So let's write on our boiling point and melting point on here. So the melting point is 1085, which is going to be round about here, I would say. That's going to be your melting point. And your boiling point, 2562. So let's put that here somewhere, just above 2,500. And again, let's make sure we section this off so that we can see the three different sections of our number line. Okay, so colder than the melting point, the cold end down here, we're going to have a solid. Heat your solid up until it melts, goes past the melting point, and it will become a liquid. Heat your liquid up past its boiling point, and it becomes a gas. So now we've got our number line again. We can go back to the question, we can have a look at which temperatures we need, and we can mark these on our number line. So minus 100 is your first one. Minus 100 is so low, it's not even on our number line. So it's going to be over that direction somewhere, minus 100 degrees C. Which section is it in? Solid, liquid or gas? It's in the solid section. So minus 100, copper would be a solid. Your next one is 20 degrees. Again, 20 degrees, miles away. It's over this end somewhere. And again, it's in your solid section, so it's going to be a solid. 200 degrees, even 200 degrees doesn't fit on our number line because we're starting at 500. So even something as high as 200 degrees is still going to be way over here somewhere. So all three of these temperatures, minus 100, 20 and 200, they are all in our solid section of the number line. So that would also be a solid. And that's how you answer those questions. So you've told me what state of matter copper is at those three temperatures. That's how you work it out. So each time you need to start by knowing the melting point and the boiling point. You need to draw a number line that will fit those numbers on. Mark on the melting point, mark on the boiling point, and mark on your solids, liquids and gas sections. And then it's just a case of finding these numbers where they sit on your number line. And it's as easy as that. And you can't go wrong if you do it that way. Okay, let's have a look at another one. Okay, sometimes you don't even need to know the name of the substance. So this just says substance A. We don't really know what it is. But in that sort of case, you will have a melting point and a boiling point given to you. So I'll show you those now. So this substance A, whatever it happens to be, question tells us it's got a melting point of 56 degrees and it's got a boiling point of 120 degrees. So we're going to draw a nice straight number line. And on our number line, we want to make sure we can get those numbers 56 and 120. So let's figure out a nice times table. It's going to take us all the way between 56 and 120 degrees Celsius. Now you could actually use any numbers you like as long as you can draw your number line big enough. So let's go for tens. I'm going to draw these on. Okay, so there it is in tens. I mean, I could just as easily have done it in 50s. So I could go from 0, 50, 100, 150, 200, and that would be just as good a number line. It doesn't really matter. It's whatever you want it to be. So don't worry about thinking that you've done something wrong. So I'm going to go for tens this time, and I'm going to mark on the melting point and the boiling point. So the melting point is 56, so it's going to be roughly here. And the boiling point is 120, which is here. Let's section off our number line so that we can see our three distinct sections, and let's highlight where our solids, liquids and gases are. Solids are the coldest, so they're going to be the cold temperatures below the melting point. Oh, that's a highlighter. Didn't mean to use a highlighter. There we go, solid. If you take your solid and you heat it past its melting point, it will become a liquid. And if you take your liquid and you heat it past its boiling point, it will be a gas. So there's our number line, all ready to go. Let's have a look for these temperatures now. So our first one is minus 100 degrees, and you can see that our number line only goes down to 10. So minus 100 is way over to the left somewhere. But we can still mark it on. Don't know whereabout it is exactly, but it's somewhere over there. It's minus 100 degrees Celsius. And we can see that that would put it in the solid section. So this substance A at minus 100 would be a solid. That's what the melting point and boiling point tell us. 20 degrees, let's have a look. 20 degrees would be here. And you can see that 20 degrees is also in the solid section. So this substance A is going to be solid at 20 degrees. 200 degrees is, it's not even on our number line, it's way up that way. So 200 degrees is off the scale to the right, but you can see that it's in the gas section. So 200 degrees, this substance would be a gas. And that's how you'd work it out for that one. So you can see that all you really need each time is the melting point, the boiling point, and then a number line that you're going to mark on melting point, boiling point, solid, liquid, gas, and try and take these up in a nice times table so that you can see where the numbers go. And that's pretty much it, and you can do that then for any substance at all. One thing to be wary of is sometimes your melting point and your boiling point might both be negative numbers, so you have to get good at drawing a negative number line. So I'll show you one example like that next. Okay, so this question says, what state of matter is oxygen at these temperatures? Now for oxygen, the melting point is minus 219 degrees Celsius, and the boiling point is minus 183 degrees Celsius. Now you have to be very careful because in your questions sometimes people don't notice a minus symbol, but it's obviously so important to get the answers right. So for this one, let's draw our number line again. Okay, so on our number line we need to make sure we can fit minus, I'm going to go all the way to minus 300. Okay, and we also need to fit minus 183, so I'm going to go a bit warmer than that. I'll go all the way to 0. Okay, so we'll go for minus 300. If we put 0, let's say 0 there, can we go down in minus 50 each time? So let's go to minus 50 degrees Celsius, minus 100 degrees Celsius, minus 150 degrees Celsius, minus 200 degrees Celsius, and minus 250 degrees Celsius. Now that's not a perfect number line, so this gap's huge and this gap's only little, but it doesn't matter because it still works. It's just to help us with working out for now. It doesn't need to be perfect. Okay, so our melting point and boiling point will both fit on this, and this is a negative number line because the numbers seem to go bigger as you go to the left, but there's a minus symbol, so actually they're getting very, very small. Okay, melting point is minus 219, which we will put here. Melting point, so somewhere between minus 200 and minus 250, a little bit closer to minus 200. So melting point could go there. Boiling point is minus 183, so 183 is going to be there somewhere. Okay. If your numbers are very close together, like these are fairly close together, you might even want to write it on minus 219, minus 183, so that you can see it. Let's section off our number line. Okay. Now, very, very cold, colder than the melting point. We've always got, done it again, we've always got a solid. Heat your solid past its melting point, it will melt into a liquid, and this substance, oxygen, is clearly only a liquid for a few temperatures, small range of temperatures. Heat your liquid past its boiling point, it will become a gas. Okay, so there's our number line ready to go. So let's look at these questions. We want to know at minus 100. Let's find that and mark it on. Minus 100 degrees Celsius is here, and it's in the gas section. So minus 100, it would be a gas. 20 degrees is a positive number. 20 degrees is going to be off the scale that way. There we go, all the way up there, and it's still in the gas section. So 20 degrees, oxygen is a gas, we know that. And at 200 degrees, well, that's off the scale, that's going to be over here somewhere. At 200 degrees Celsius, out of our three sections, this is a solid, this is a liquid, and this end is a gas. We can see that it's still in the gas section, all the way over to the right. So at 200 degrees, it would be a gas. And that is the final example I'm going to give you, because it's exactly the same then for any questions that you've got to do that are like this. So your steps are, make sure you know the melting point and boiling point. Draw yourself a number line where they fit on. Mark on your melting point and your boiling point and section off your three different parts of your number line. Anything colder than the melting point is a solid. Anything between the melting point and the boiling point is a liquid. And anything above the boiling point is a gas, so mark those on. And then go back to your question, find the temperatures you're asked about, and find out which section they fall into, and write them down. And it's as simple as that. Some people will look at the melting point and boiling point and can just answer the questions really quickly, but if you want a foolproof way of doing it so that you'll never get it wrong, the number line is a perfect way of doing it. So try that. Good luck with those sort of questions, and thank you for watching.